welcome to the deep dive. So today we're doing something a little different. We're doing a deep dive, but in a different format than usual.
Yes, exactly.
So instead of kind of unpacking a topic like we normally do, we are going to test your knowledge with a quiz.
A quiz?
All about the moon.
Yes, the moon.
Yeah.
Our
Yeah.
nearest celestial neighbor.
Yeah.
A fascinating object in the night sky.
So we have put together 10 multiple choice questions,
Yeah, and that's right.
and there are 4 options for each question.
Yep.
And what we'll do is we'll present a question, we'll read the 4 options, and then we'll kind of discuss why some might be more plausible than others and some, obviously wrong.
Yes.
And then we'll reveal the correct answer, and hopefully along the way you'll learn some interesting facts about the moon.
Yes, and you can wow your friends with your amazing new knowledge about the moon.
Exactly. So are you ready to put your lunar knowledge to the test?
I'm ready. Let's do it.
All right. Question number 1. The same side of the moon always faces Earth. We always see the same side of the moon. What is the primary reason for this phenomenon? Is it A, the moon doesn't rotate at all? B, Earth's magnetic field has locked the moon in place? C, Earth's gravity has caused the moon's rotation and its orbit around us to sync up? Or D, the moon's core is magnetic and aligns itself with Earth?
Okay, so 4 possible options there, some more plausible than others. What do you think?
Well, A, the moon doesn't rotate at all, just intuitively sounds wrong. Because I feel like we would see the other side of the moon if it was just kind of chilling there, not rotating.
Yeah, that's a common misconception. People see the same face and they assume no rotation, but that's not how it works. Think about it. If the moon were tidally locked but not rotating, we would actually see all sides of it as it orbits us, right?
Yeah.
Over the course of a month.
Right.
So we can rule that one out straight away.
Okay, so what about B? Earth's magnetic field has locked the moon in place. Earth does have a very powerful magnetic field, but I don't know. I don't think a magnetic field could hold something that big in place.
Yeah, it's an interesting idea, but the magnetic field, yeah, it's strong, but its main interaction is with charged particles.
Yeah.
Like the solar wind, not with massive objects like the moon.
Right.
It doesn't have that kind of grabbing power.
So not B.
No.
Okay.
What about D?
The moon's core is magnetic and aligns itself with Earth.
So we do know that the moon has an iron-rich core.
Yeah.
And there's actually evidence that billions of years ago, it had a much stronger magnetic field than it does now. But currently, it's very weak. It's far too weak to be the reason for this fixed orientation that we see.
Right, so that leaves C.
Yes.
Earth's gravity has caused the moon's rotation and its orbit around us to sync up.
That sounds pretty plausible to me. What do you think?
Yeah, it does. It makes sense that Earth's gravity could have that kind of effect over, billions of years.
Yeah, and it's not just a kind of gentle influence either. This is about tidal forces.
Right.
The same thing that causes the tides in our oceans. Earth's gravity is pulling on the moon, creating these bulges. And over a very, very long time, that tugging has slowed the moon's rotation down until it matches its orbital period. It's imagine a cosmic dance where one partner finally learns to match the other one's steps perfectly.
I love that.
Yeah. So that's the answer, C.
Okay, so the answer is C. Earth's gravity is the reason why we see the same side of the moon.
Yes, and this synchronization, this locking, it's actually called tidal locking.
Catchy.
It has a really fascinating consequence. A lunar day that's one full rotation of the moon relative to the sun is about 29.5 Earth days.
Wow.
The same as its orbital period.
That's amazing.
It's a lunar month. Amazing how gravity orchestrates these movements over such vast distances in space.
It really is incredible. Okay, ready for question 2?
I am. Hit me with it.
Okay. Approximately how far away from Earth does the moon orbit on average?
Yeah. Ooh, that's a good one.
Is it A, 38,000 kilometers, which is about 23,600 miles, B, 384,399 kilometers, or around 238,854 miles, C, 3,800,000 kilometers, about 2,360,000 miles, or D, a whopping 38,000 kilometers, roughly 23,600,000 miles.
Okay, so we've got some pretty big numbers there to contend with.
We do, and some of them I think we can rule out pretty quickly. I'm going to say 38,000 kilometers is way too close.
Yeah, that's like a, quick hop in space terms,
Yeah.
it would feel way too close for something that dominates our night sky.
It's closer than some satellites.
Yeah, exactly. Some satellites are further out than that. So 38,000 we can rule out. What about the other end of the spectrum, 38 million kilometers?
Yeah, that seems like way too far. That would mean, missions to the moon would take months or even years.
Yeah, we know from the Apollo missions and even more recent robotic missions, it doesn't take that long to get there.
Right.
So we can probably safely rule out D as well.
Okay, so we're left with B and C, 384,399 kilometers, or 3,800,000 kilometers.
This is where it gets a bit trickier.
Yeah. I mean, both of them sound like they could be plausible.
Yeah. I mean, they both represent, significant distances.
Right.
The moon isn't exactly next door, but maybe if we think about it in terms of Earth's size.
Okay.
Earth's diameter is roughly 12,742 kilometers.
Okay.
So how many Earths could you fit between us and the moon?
Let me see. Well, 384,399 kilometers is about, I don't know, 30 times Earth's diameter.
Okay, that's a good point. So you could fit about 30 Earths in that distance.
Okay. What about the other one? 3,800,000 kilometers.
That's going to be a lot more Earths. I don't think that's quite right.
Right. That would be like hundreds of Earths.
Yeah.
So I'm going to go with B.
I think you're right.
384,399 kilometers.
And you are absolutely correct.
Yeah.
That is the average distance. It varies a little bit because the moon's orbit isn't a perfect circle. It's slightly elliptical, but on average, it's about 384,399 kilometers, roughly 30 times the diameter of Earth.
Wow. All right, so 2 for 2. Ready for question 3.
Hit me with it.
Question number 3.
Hmm.
Compared to Earth's gravity, what is the moon's surface gravity approximately?
Right.
Is it A, 1/10, B, 1/6, C, 1/2, or D, the same?
All right. Well, I think we can rule out D straight away.
The same.
Yeah, the same. I mean, we've all seen the footage of the Apollo astronauts bouncing around on the moon.
Right.
If the gravity was the same, they wouldn't be able to do that.
Yeah, they would just be walking around like they normally do.
Exactly. They would be walking normally.
Okay.
What about A?
1/10.
1/10. That sounds really, really light. Like, I almost feel like you would just float away.
Yeah, I mean, with gravity that weak, you'd barely be able to stay on the surface.
Yeah.
You'd have to be very careful. So I think we can probably rule that one out as well.
Okay.
What do you think about C, 1/2?
1/2. So, like, half as heavy as on Earth. I don't know. Doesn't seem quite right.
Yeah, I mean, it would be a noticeable difference.
Yeah.
Like you said, you'd feel lighter.
Yeah. But I'm not sure if it would account for the kind of, the giant leaps that we see the astronauts taking.
Right, exactly. Okay, so that leaves B, 1/6.
1/6. That seems to be the most likely. What do you think?
Yeah, I think so too. It's definitely less gravity than Earth, but not so little that you would just, float off.
Exactly. So the answer is B. You are correct again.
Yay.
1/6 of Earth's gravity.
And that makes sense because the moon is smaller and less massive than the Earth, so, gravity is related to mass and size.
Exactly. And it's interesting to note that even though the moon is quite small compared to Earth, it actually has the second highest surface gravity among all the moons in our solar system.
Wow, I didn't know that.
Yeah, the only one with higher surface gravity is Jupiter's moon Io.
Interesting. All right, question 4.
Okay.
This one takes us back in time. We're talking about the formation of the moon.
The origin story.
Yes, the origin story. What is the widely accepted scientific theory for how the moon formed?
Okay.
Was it A, it was captured by Earth's gravity? Okay.
B, Earth and the moon formed simultaneously from the same cloud of gas and dust. C, the moon broke off from a rapidly spinning early Earth. Or D, a giant impact occurred between Earth and a Mars-sized body called Theia.
Okay, 4 interesting options there.
I like A. It's kind of romantic, like Earth just captured the moon.
I know, it was like a cosmic love story.
It is.
But the problem is, if the moon was just a random object captured by Earth's gravity, then its composition would be very different from Earth's.
Okay. Yeah, that makes sense.
And we know that the moon's mantle, the layer beneath its crust, is actually very similar to Earth's mantle.
Okay. What about B?
Earth and the moon formed simultaneously from the same cloud of gas and dust. That was actually a popular theory for a while, but it also has some problems.
Like what?
Well, if they formed together from the same material, then we would expect their overall composition to be much more similar
Right.
than it actually is. For example, the moon has a much smaller iron core relative to its size than Earth does.
Okay.
So that kind of throws a wrench in that theory.
Yeah.
All right. What about C? The moon broke off from a rapidly spinning early Earth.
Oh, I like that one.
It's dramatic.
It is. It's like piece of the Earth just flew off.
Yeah.
And it's visually very compelling, but it doesn't quite work either.
Why not?
It's all about angular momentum.
Okay.
The Earth-Moon system has a certain amount of angular momentum, which is basically a measure of how much it's spinning and orbiting.
Okay.
And if the moon just spun off from the Earth, the system should have a different amount of angular momentum than it does now.
Huh. Okay, so that leaves D.
Yes, the giant impact theory.
The giant impact occurred between Earth and a Mars-sized body called Theia.
Exactly. And this is the theory that most scientists now accept as the most likely explanation for how the moon formed.
Okay, so tell me more about this theory. Like, what happened?
All right, so imagine this. About 4.5 billion years ago, the early Earth was still forming.
Okay.
And along comes this Mars-sized object called Theia,
Theia.
and it smashes into the Earth.
Oh, wow.
Yeah.
That's a big impact.
Huge impact. Just a cataclysmic event. And this impact blasted a huge amount of material, mostly from Earth's mantle, out into space. And this debris, it didn't just fly away, it started orbiting the Earth.
Okay.
And over time, it clumped together under its own gravity.
And that formed the moon.
Exactly.
So that's why the moon's mantle is so similar to Earth's.
Yes, because it came from the same place.
Wow.
And it also explains why the moon has a relatively small iron core, because most of Theia's core would have sunk into the Earth during the impact.
Wow. Okay, so the answer is D, the giant impact theory.
Correct.
So that means the moon that we see every night is actually the result of this, ancient cosmic collision.
Exactly. And it's a good reminder that our solar system has a very violent history.
Yeah, no kidding.
Yeah.
Okay. On to question number 5.
All right.
This one's about the moon's atmosphere.
Okay.
So does the moon have an atmosphere?
Good question.
A, yes, a thick atmosphere, much like Earth's. B, yes, a thin atmosphere, primarily composed of nitrogen. C, yes, a very, very thin exosphere, which is almost a complete vacuum. Or D, no atmosphere whatsoever.
Okay, well, I think we can rule out A straight away.
A thick atmosphere, much like Earth's.
Yeah, I mean, if the moon had a thick atmosphere like Earth, we would definitely see weather patterns.
Yeah.
Clouds, winds.
Rain.
Exactly.
Sure.
Yeah, and we don't see any of that.
No, we don't. So A is definitely out.
Okay. So what about B?
Yes, a thin atmosphere primarily composed of nitrogen. Nitrogen is a common element in atmospheres.
Right, like on Earth.
Exactly. But we haven't really detected significant amounts of nitrogen around the moon.
Okay.
So I'm not sure about that one.
And what about D?
No atmosphere whatsoever.
Yeah, I mean, it looks like there's nothing there.
It does, doesn't it?
Yeah.
But it's not completely true. The moon actually does have a very, very thin layer of gas around it.
Which brings us to C. Yes, a very, very thin exosphere, which is almost a complete vacuum.
Okay, so it does have an atmosphere, but it's extremely thin.
Exactly.
And what is an exosphere?
An exosphere is basically a region where the gas molecules are so spread out, they rarely collide with each other. It's like the outermost layer of an atmosphere.
Okay.
And on the moon, this exosphere is incredibly tenuous. I mean, we're talking about a near perfect vacuum.
Right.
So the answer is C.
Okay. And what exactly is in this very thin exosphere?
It's made up of a variety of elements, but in very small amounts. We're talking helium, argon, neon, sodium, potassium, things like that. And these gases, they actually come from different sources. Some of them are released from the moon's interior through a process called outgassing.
Okay.
And others are, they get knocked off the surface by the solar wind.
Oh, wow.
Yeah.
So the answer is C. It has an exosphere, which is basically just a very thin layer of gas.
Yes, and it's interesting to think that billions of years ago, the moon might have actually had a thicker atmosphere. Yeah, scientists think that volcanic eruptions on the moon could have released a lot of gas.
Oh, wow.
But over time, the moon's weak gravity just wasn't strong enough to hold on to it, and it dissipated into space.
Fascinating. All right, ready for question 6?
I am. Let's hear it.
Question number 6. What is the term for the large, dark plains on the near side of the moon?
Good question.
Is it A, highlands,
Yeah.
B, craters, C, Maria, singular mare, or D, rills?
Okay. Well, I mean, highlands and craters are definitely features we see on the moon.
Right.
But those aren't the dark plains. Highlands are actually the lighter areas.
Oh, okay.
And craters are, the impact craters scattered all over the moon.
Right.
What about D-rills?
Rills. I've never heard of that.
Rills are these interesting, long, narrow depressions. They kind of look like trenches,
Okay.
and they run across parts of the lunar surface. They can be pretty long,
Okay.
but they're not the large, dark plains that we're talking about. So that leaves C, Maria.
Maria. That sounds familiar. I feel like it has something to do with water.
You're on the right track. It actually comes from the Latin word for seas,
Oh, okay.
because early astronomers, when they first looked at the moon through telescopes, they thought these dark areas were oceans.
Oh, wow.
Yeah, they didn't know any better.
But now we know they're not seas.
Well, we know now that they're vast plains of solidified lava.
Oh, wow. Wow.
So ancient volcanic eruptions created these features.
So the answer is C, Maria.
That's right. And it's interesting to note that most of these Maria erupted billions of years ago, primarily on the near side of the moon, which is, the side that always faces us.
Yeah.
Why is that?
That's a good question, and scientists are still trying to figure that out.
Fascinating. All right, question 7.
Hit me.
This one is about a really big crater.
Okay.
What is the name of the largest known impact crater on the moon and the second largest confirmed in our entire solar system?
Wow, the second largest in the solar system.
Yeah, in the solar system.
Okay, so we're talking big.
We are talking big.
Is it A, Mare Imbrium, B, Tycho Crater,
Yeah.
C, South Pole Aitken Basin,
Right.
or D, Mare Tranquillitatis?
Okay. Well, we know that Mare refers to those lava plains, right?
Right.
So we can rule out A and D straight away
Okay.
because we're looking for a crater.
Right.
What about B?
Tycho Crater.
That's a famous one. It's a very prominent crater. It's got those bright rays of material that spread out from it.
You can even see it with a small telescope, right?
Yeah, exactly. It's very visible. But I'm not sure it's the largest crater on the moon, let alone the second largest in the solar system.
Yeah, I probably wouldn't even be in the top 10 in the solar system, right?
Probably not.
Okay, so that leaves C, the South Pole Aitken Basin.
Yeah, and that name itself kind of gives it away.
Right, it sounds big.
A basin.
Like a giant
A
basin.
basin. It's massive. It's on the far side of the moon, and it spans, get this, 2,500 kilometers in diameter.
Wow. How big is that compared to, like, something on Earth?
That's roughly the distance from New York to Denver.
Wow, okay, that's a really big crater.
And it's deep, too.
How deep?
About 13 kilometers deep. It's the lowest point on the moon's surface.
So the answer is C, the South Pole Aitken Basin.
Exactly. And to think that massive crater was formed by an impact billions of years ago.
Wow. Okay, on to question 8.
Huh?
This one's about something that, you might not expect to find on the moon.
Oh, okay.
Water.
Water.
Yeah.
Interesting.
Evidence suggests the presence of water. In what form on the moon?
Okay.
A, vast underground oceans. B, liquid water flowing on the surface. C, water ice in permanently shadowed craters at the poles and water molecules bound in minerals. Or D, water vapor throughout its atmosphere.
Okay. A lot of different forms of water there.
Yeah.
Well, based on what we talked about earlier about the moon's atmosphere, I think we can rule out D straight away.
D, water vapor throughout its atmosphere.
Right. The atmosphere is way too thin to hold any significant amounts of water vapor.
Okay. And what about B, liquid water flowing on the surface?
I mean, we haven't seen any rivers or lakes on the moon.
No, definitely not.
And even if there was liquid water, it would quickly evaporate because there's no real atmosphere to protect it from the sun.
Okay.
And the temperature swings on the moon are extreme, so I think we can safely rule out B as well.
All right. So that leads A and C. Vast underground oceans or water ice, impermanently shadowed craters at the poles, and water molecules bound in minerals.
I mean, A is definitely intriguing.
Yeah, it sounds like science fiction.
It does, but we haven't really found any evidence of massive underground oceans on the moon.
Okay.
There might be some subsurface water,
Yeah.
but nothing on the scale of an ocean.
Okay, so that leaves C.
Yes, water ice in permanently shadowed craters at the poles and water molecules bound in minerals.
And that actually makes a lot of sense because, if there are craters at the poles that are always in shadow, it would be cold enough for ice to survive.
Exactly. And there have been several missions, like India's Chandrayaan-1 mission and NASA's El-Cross mission, that have actually detected evidence of water ice in those shadowed craters.
Wow, really?
Yeah, and not just water ice, they've also found evidence of hydroxyl, which is a molecule that contains one hydrogen atom and one oxygen atom.
Okay.
And it's found bound in the lunar soil and rocks, so there's definitely water there, it's just not in liquid form on the surface.
Okay, so the answer is C.
Yes, C. And it's really exciting because it means that if we ever establish a permanent base on the moon, we might be able to access that water ice and use it for drinking, for growing plants, even for rocket fuel.
Yeah, it's a potential game changer. Okay, ready for question 9?
Hit me.
Okay, question 9. How does the moon primarily influence the Earth?
Mhm.
Is it A, by causing earthquakes, B, by influencing Earth's weather patterns, C, by being the main driver of Earth's tides, or D, by stabilizing Earth's magnetic field?
Okay, well, I mean, we do know that the moon's gravity exerts a pull on the Earth,
Right.
but I'm not sure if it's strong enough to cause earthquakes.
Yeah, earthquakes are mostly caused by the movement of tectonic plates.
Exactly. So A probably isn't right.
Uh,
What about B?
Influencing Earth's weather patterns. I mean, I've heard people say that the full moon can make people act crazy.
Yeah, there's a lot of folklore about that.
Yeah.
But scientifically, there's no real evidence that the moon has a significant impact on our daily weather. I mean, the weather is mostly driven by the sun's energy and the Earth's atmosphere.
Okay, so not B,
No. What about D?
stabilizing Earth's magnetic field? I have no idea.
Yeah, that's a tricky one.
Yeah.
It's actually a topic of ongoing research. Some scientists think that the moon might have played a role in helping to create the Earth's magnetic field early in its history,
Okay.
but it's not the primary factor that keeps it stable now.
All right, so that leaves C being the main driver of Earth's tides.
Yes, and this one is definitely true. We see the tides rise and fall every day,
Yeah.
and that's primarily due to the moon's gravitational pull.
So the moon's gravity is pulling on the water in the oceans.
Exactly. And it creates these bulges of water on the side of the Earth closest to the moon and on the opposite side.
Oh.
And as the Earth rotates, those bulges move around, causing the tides to rise and fall. The sun also plays a role in the tides, but the moon's effect is much stronger because it's closer.
So the answer is C, tides.
That's right. And it's not just the oceans that are affected by the moon's gravity. There are also tides in the Earth's solid crust, although they're much smaller.
Wow, I didn't know that.
Yeah.
Over millions of years, those tidal forces have actually slowed down the Earth's rotation.
Yes, it's incredible. Okay, ready for our final question?
I am. Hit me with it.
Question 10. What is a supermoon? Is it A, a full moon that appears blue in color? B, a full moon that occurs during a lunar eclipse? C, a full moon that appears larger and brighter because it is closer to Earth in its orbit at its perigee? Or D, a full moon that is visible for 2 consecutive nights?
Okay, well, A is easy to rule out.
Yeah,
A blue moon is just when there are 2 full moons in a month.
that's right. It has nothing to do with the moon's actual color.
Right. And what about B, a full moon that occurs during a lunar eclipse?
So a full moon during a lunar eclipse often does appear reddish,
Yeah.
like a coppery red.
Blood moon.
Yeah, a blood moon.
Yeah.
But that's because of the way sunlight is filtered through the Earth's atmosphere during an eclipse.
Right.
And it's not what makes a supermoon.
Okay. And what about D?
A full moon that is visible for 2 consecutive nights.
Well, I mean, full moons are usually visible for a couple of nights.
Yeah, that's just a normal full moon.
Yeah.
Nothing super about that.
Okay. So that leaves C,
Yes.
a full moon that appears larger and brighter because it is closer to Earth in its orbit, specifically at its perigee.
Exactly.
So it has to do with the moon's orbit.
Yes, the moon's orbit around Earth is not a perfect circle. It's slightly elliptical.
Okay.
So there's a point where the moon is closest to the Earth, and that's called perigee.
Okay.
And when a full moon happens to coincide with perigee, it appears larger and brighter in our sky, and that's what we call a supermoon.
Okay, so the answer is C.
Yes, C. And it's not just a tiny difference either. A supermoon can appear up to 14% larger and 30% brighter than a regular full moon.
Wow, that's actually quite noticeable.
Yeah, it's pretty spectacular.
Well, that brings our lunar quiz to an end.
How do you think you did?
I think I aced it.
Yeah, me too.
I learned a lot.
Yeah, me too. It's amazing how much there is to learn about our nearest celestial neighbor.
It is. You know, we see it in the sky all the time, but we don't always stop to think about all the amazing things about it.
Yeah, it's easy to take it for granted.
Yeah, and, from its dramatic birth and that giant impact to the way that it controls our tides.
Yeah, it's incredible.
The moon has a really fascinating story, and, we're about to enter this new era of lunar exploration with missions planned to go back to the moon, even plans for a permanent base.
Yeah, it's exciting to think about.